This is just a short video on the algebra of trig identities. All of this is completely a review from Algebra 2, but these skills are necessary for being successful in the next unit. On page A27, this is A27, there are some formulas for factoring polynomials that you're going to need to either memorize or be able to reference them quickly. U squared minus v squared is equal to u plus v times u minus v. This is called the difference of squares. Go ahead and copy all of these formulas down. We have the perfect square trinomial, subtraction and addition, and then we have the addition and subtraction of cubes. These formulas need to be memorized. There's tricks to doing that. Like I said, you either memorize them or be able to reference it on page A27. All right, go and write this one down. This is example number 6. We're close to that same page. I'm asking you to factor this. The first thing you should do is factor out the common factor between those values, which is 3, which leaves us with 1 minus 4x squared. Using the formulas you just wrote down in your notes, we have u squared minus v squared. That means this is u, not u. We have 1 squared, which turns into 1, minus the 4x squared square rooted, which is 2x, and we have 1 plus 2x, and this gets multiplied by 3. And then from there, that was it. So this is completely factored form of this by first removing a common factor. Alright, if you're asked to factor 16x to the 4th minus 81, we need to find this as perfect squares. Notice this is 4x squared minus 9 squared. That makes it the difference of squares. This gives us 4x squared minus 9 times 4x squared plus 9. We're actually not done because the difference of squares can be factored. The sum of squares can't. So this becomes 2x minus 3 times 2x plus 3, but we still have the 4x squared plus 9. And that's it for that one. A trick for remembering the sum of cubes is that the positive becomes positive, which means they're like signs, and the negative is a different sign than this one. But as far as the difference of cubes is concerned, notice we have like signs here, and then these are different signs. That should help you to remember them. It's just a trick to get through it. With that in mind, this becomes pretty simple. It's x minus, now the cube root of 27, notice 3 times itself 3 times is 27, so it's x minus 3. These are the same signs. These right here are the same signs, but these are different signs. X squared plus, now this becomes the u times, the 2 times u times v, and so 2 times u, and u is x, and v is 3. And then, I apologize, not 2 times it. We just have u times v right there, so it's just 3 times x. And then we have the plus v squared, and v in this case is 3, which is 9. That is the factored form. You could try to factor this one again, but chances are it's not going to work out. 2 numbers multiplied to get 9, add to get 3. Yep, not factorable. So this is it. Just going to talk through this problem number example number 10, number A. Notice we have the sum of cubes, so we find them out as cubes, knowing that 8 is 2 cubed, and it's the same sign as this, and these are different signs, and this is 2 squared. Okay, the next concept I'd like to go through to illustrate simplifying trig identities later on in algebra is simplifying a rational expression. Notice we have a trinomial on top and a binomial on bottom. We need to find common factors so that we can delete those, or sorry, not delete, and we can cancel out those common factors. So the bottom has 3 times x minus 2 if I factor out that 3. The top one needs to be factored. We need to find 2 numbers that multiply to get negative 12 and add to get 4. If they multiply to get a negative, one of them is positive and the other is negative. So now it just comes down to finding values that satisfy those cases. Now if this is positive, the bigger one is positive. Notice if we have 6 and 2, that should work out. The bigger one needs to be positive because they add to get a positive, but one of them has to be negative, so it's 2. Notice in this we have the x minus 2 factor cancels with this x minus 2. Remember the original function would have a whole here, but we're just simplifying this, so it doesn't matter quite as much. So we just x plus 6 over 3. Next example is a little trickier to factor. I'm going to go ahead and factor the top, and then I'm going to worry about the bottom one. Notice we're looking for two numbers that multiply to get positive 12 and add to get positive x. But the problem here is that we have a negative x squared. My personal preference is to turn that all to be negative by factoring out that negative 1. So we get x squared minus x minus 12. It just looks a little bit more of a familiar form for me. I'm still going to leave the 2x squared minus 9x on the bottom plus 4. I need to find the two numbers that multiply to get the 12, negative 12, and add to get negative 1. That means one of them must be negative and the other must be positive. So let's see. We got 12 and 1. Nope. They need to be close to each other. 4 and 3 should work, but they need to be negative. So negative 4 and positive 3 should work. And that does check out for the top. I'm just leaving that negative 1 alone for a second. Now I need to worry about this 2, the coefficient of a being, or of x squared being a little bit bigger than, or bigger than 1. What I like to do is take the 2 and the 4, multiply them, take the negative 9, and ask what two numbers multiply to get the 8 and add to get the negative 9. Well, if they multiply to get a positive and add to get a negative, then both have to be negative. That means it's negative 8 and negative 1. I'm going to factor this 2x squared right beneath it. So we have 2x squared minus 9x, but 9x can be turned into minus 8x and minus 1x. We still have the plus 4. Then I'm going to factor by grouping. So I have these two terms have a 2 and an x. So then I'm left with, let me scroll down, 2x, and I'm left with an x minus 4. Over here, if I factor out a negative, I have x minus 4 as well. Tricky part is seeing that if I factor out a negative here, it becomes negative 4, x minus 4. So this can be pulled out to become x minus 4 times 2x, and when you factor out the x minus 4 here, we're left with minus 1. So x minus 4 times 2x minus 1. Now it just comes down to simplifying. X minus 4 cancels with this, and I like to put the negative back inside once I'm done with that. So negative x minus 3 over 2x minus 1. Now there are actually many ways we can get through this. Sometimes it's preferable to change the form of this answer. And this would be a true value, but the way the textbook has it is negative of x plus 3 over 2x minus 1. Either way would be acceptable later on, but my personal preference is that one. The next concept is what I call the butterfly method, and it is probably one of the trickiest things to do with trigonometry, yet it's something that you learned as far as the process is concerned in middle school. It's the whole process of adding fractions. Like let's say I have 1/2 and 2/3, and I want to add these two fractions. I've got to take these two fractions and put it through this process. Let's do that. So we have 1/2, this 2 goes to the 2, 3 goes to the 1, and 2 goes to the 3. Just like if I were standing in Kung Fu method for butterfly. That's just a stupid way to help you remember this. That becomes 3 plus 4 divided by 2 times 5, which is 6. 3 plus 4 is 7. This is 7/6. That is just a fast way to get through this, and this is a necessary skill. But let's go through some problems with some algebra. Like let's say we have this problem. We need to simplify this by combining the two rational expressions. Using the butterfly method, top to bottom, or bottom to top, and then bottom to bottom, we can simplify. So let's do that. We got the x times the 3x plus 4. Then we have the minus because the operation gets carried, minus the 2 times the x minus 3, all over the denominator times the denominator. Alright, now it just comes down to simplifying. Got the x, need to distribute. The negative 2 gets distributed. And then let's FOIL the bottom. (3x squared) plus 4 times x, or 9, minus 9x, plus 4x minus 12. And that's about as far as you can go with it. The whole point here is being able to add fractions using the butterfly method. Another example you will see a lot in trigonometry is one like this algebra, where it's simplifying complex fractions. You're going to have to do the butterfly for the top and for the bottom. I went ahead and changed my font size on my pen because I'm going to need a lot of space. Alright, so I'm going to put this over 1, and I'm going to do the butterfly. So that's this to this, this to that, and this to this. So, clean that up. That's 2 times 1 minus 3 times x, all divided by x times 1. All of this is being divided by the bottom, and I'm going to put this over 1, and I'm going to do the butterfly method. X minus 1 minus 1 times 1, all over x minus 1 times 1. I'm going to simplify before I continue to the next value. By the way, some of you might not have caught what I did. Bottom to top with this operation, and multiply the bottoms. That's just a butterfly method. This is 2 minus 3x over x, but this fraction can be simplified. X minus 2 over x. Now, dividing by a fraction, this fraction, this is the case I'm talking about, is the same thing as multiplying by the reciprocal. So that's what I'm going to do here. So times x divided by x minus 2. Noticing the x's cancel, and I've got 2 minus 3x all over x minus 2. That's about as far as you can go with it. Notice this is much simpler than this complex fraction. Working with trigonometry and the trig identities, sorry about the bell, this happens quite a bit. I don't have time to go through this one in the video. I'm just going to emphasize the part that you need. Remembering that negative fractions mean reciprocals. So this negative 3/2 means that you put it on the bottom and make it 3/2. That's one of the key concepts, but I will be reviewing this more in depth when we go through some problems in trig that involve it. That's it for the basic review that I wanted to go through on algebra before we get into trig identities.